Okay, so this is quantitative homework number 3. I have made my own little template that if you would like it to do the homework with, just ask me and I'll gladly provide it to you. All the data is already downloaded and set up, and what we're doing in this homework is doing all the different two-tailed confidence intervals that we can have for mean, difference of mean, variances, and comparing variances. So just one quick disclaimer before I start. Make sure you're always reading the formulas very carefully for each one. It's very easy to get confused between S or sigma, which is standard deviation, and S squared or sigma squared, which is variance. So I'm going to try my best not to screw that up, but if I do make a mistake, just always keep your eye on the formula and take that with a grain of salt. So without further ado, let us begin with the first confidence interval. The first one we have is a two-tailed interval estimate for the mean, assuming normal distribution. So we're working with the mean, which means we're going to be using t or z, and normal distribution means we're going to be using a t-test. Now, with the t-test, there is the two-tailed option. So for our alpha in Excel, we can just put 0.05, and Excel will divide it in half for us since it's two-tailed. So let us start by doing our t-value. It's very simply t.inverse.two-tailed. And we know that we need to use inverse because we're going to feed Excel an alpha and a degrees of freedom. And the degrees of freedom here is simply n minus 1. As you can see, it's just n minus 1, the count minus 1. And our alpha gets divided in half by Excel for the two-tailed value. So that's our t-value. And now let's build our confidence interval based on this formula over here. So our confidence interval is the mean. And we're doing the lower end of the confidence interval, so we're going to subtract our t-value to get a smaller number and multiply that by the standard deviation divided by the square root of n. Now n is the sample size, but we only have degrees of freedom here, so we're going to have to do the degrees of freedom plus 1 to get our sample size. Oh yeah, add another parentheses. Okay, so that gives us our lower end of our confidence interval. Now, in order to know that we did this correctly, we should get a higher end as well. So let's do that real quick. We're going to do our mean of Amazon again. This time we're going to do plus our t-value because we want the upper bound. All that times our standard deviation divided by the square root of our degrees of freedom plus 1 because we need our sample size. And we get 0.0006 and 0.002, so this is smaller, this is larger. Okay, so that is our first confidence interval. So if we were looking, if he was asking us, is the mean, if 0 fell within our confidence interval or something like that, we would be able to say that no, it does not, because 0 is significant because it does not fall within our confidence interval. Okay. Let us look at our next one. This is a two-tailed interval estimate for the mean, not assuming normal distribution, but large n. So as soon as we see large n, we instantly think z. And the reason we like z is because we don't have any degrees of freedom. The one confusing thing about z in Excel is that there is no two-tailed option, so you have to divide your alpha in half for Excel if you're doing a two-tailed test. So with that in mind, the formula is norm for normal, dot s because we're doing a sample, and inverse again because we're feeding it a probability, and it's going to give us a number, spat out a negative number. So now for our confidence interval, we're just going to follow the handy dandy formula. You take your mean of Amazon, and since this is negative and we want it to go down, we're going to add the negative value because plus and minus makes minus, so that'll make the lower end get smaller. Multiply that again by our standard deviation of Amazon, and all of that divided by the square root of the sample size. Now in this one I just had sample size, so you don't need to do plus 1. And again, that you'll see that it's a very comparable number to our t-distribution, but because it's z, it's slightly more, a t is just an approximation of the z distribution. So this is a slightly more accurate depiction, but they're very close. Now we'll do the high end. Again, we're going to do the mean of Amazon. And this time we want the number to go up. We want it to be the upper end of our confidence interval. So we're going to do minus, because minus and minus makes a plus. All of that times our standard deviation of Amazon divided by the square root of our sample size. and we get our upper bound. Okay, so far those are pretty straightforward. You just have to know when to use t and z. So now we're doing difference of means. So this is a two-tailed interval estimate for the difference in means, assuming normal distribution and equal variances. So normal distribution, equal variances, that means we're going to be using t, and if the variances are equal, we're going to be using a pooled variance. And as far as the confidence interval, since we're comparing the means, we're not going to be doing a separate confidence interval for Amazon and a separate confidence interval for Apple. We're going to be doing one confidence interval to compare the two means. I forgot to mention, by the way, I didn't do these ones because, just for the sake of time, it's the exact same thing as what I did over here. So just one's for Amazon, one's for Apple. But for this one, we're comparing them, so we only need one confidence interval. The first thing that we're going to use, again, is our t-value. Just one thing to note, in this t-value, since we're using two samples now combined, our degrees of freedom are now combined. It's the first sample size plus the second sample size minus 2, instead of just one of the sample sizes minus 1. So let's now do our t-value. Again, we're going to do t.inverse.two-tailed. Feed it alpha as our probability. It'll divide that for us. And our degrees of freedom is the one that we said where it's both degrees of freedom combined. So that's our t-value. Now, before we can build our confidence interval, you see that we have pooled variance in this formula, so we need to calculate that. So let's very quickly do that. It's this formula right here. So it is the square root, and let's open up some parentheses. The first phrase is the Amazon sample size minus 1 times the variance of Amazon. All of that plus Apple's sample size minus 1 times the variance of Apple. Okay, all of that, close parentheses, and divide it by Amazon sample size plus Apple sample size minus 2, which is in fact our degrees of freedom. And we get our pooled variance. Okay, so now for our confidence interval. Simply follow the formula. It's a difference of means, so we're going to take Amazon minus Apple. And since we're going for the lower end, we're going to do minus, oh, oops, I did the wrong, here, that should be the mean, there we go. We're going to do minus our t-value because it's positive, so we want this number to go down. All of that times our pooled variance, and all of that times the square root of 1 divided by sample size of Amazon plus 1 divided by the sample size of Apple. And we get the lower end of our confidence interval. Now let's do the upper end. We're again doing difference of means, so it's the mean of Amazon minus the mean of Apple, and this time we're going to do plus because we're going for the upper bound, our t-value. That again times the same pooled variance, and that pooled variance again times the square root of 1 over sample size of Amazon plus 1 over the sample size of Apple. So if you know how to read the formulas, you can see this is pretty easy. And again, it's a good indicator that we did it correctly because we got a low number here and a high number here. So if we were checking to see if the difference of means equaling 0 was significant or not, we would say 0 falls within our confidence interval, so no, it's not significant. If we were checking 1 or something, or even 1%, we would say yes, it is significant because 1 would not fall in our confidence interval. Okay, now again, continuing with difference of means, two-tailed interval estimate for the difference in means, assuming normal distribution and not equal variances. So now we can't just use a handy-dandy S pooled in our formula because our variances aren't equal. They don't have the same weight, and so we have to do some adjusted degrees of freedom magic in order to make that happen. And if we need to use adjusted degrees of freedom, we know that we can't just plug in our normal t-value. I'll show you, because if I do t.inverse.two-tailed and I use this alpha and this degrees of freedom, it's actually going to give me the wrong t-value. So here, let's copy that and put it over here. And you'll see when we do the t-value with the adjusted degrees of freedom, it'll actually give us a slightly more accurate value. So I already calculated the adjusted degrees of freedom. It's this formula here because it's quite a mouthful, but I'll just quickly run through it. So the top part of the phrase is you take the variance of Amazon and divide it by the sample size of Amazon. That's this. Add it to the variance of Apple divided by the sample size of Apple, and that whole thing you square. So that's just our numerator. Now for our denominator, we have two phrases. First, we have the variance of Amazon divided by the sample size of Amazon squared. that little bit divided by sample size of Amazon minus 1, and then you add it to the variance of Apple divided by the sample size of Apple squared, so that little thing gets squared, that little tidbit divided by sample size of Apple minus 1, and that whole thing is your denominator. And that'll give you your adjusted degrees of freedom. So now we can calculate our t-value. And you see in the formula, adjusted degrees of freedom is this df tag. I think on my formula sheet I might call it just ADJDF for like adjusted degrees of freedom, but if you know that the variances are not equal, you're using that. So let's do this. T dot inverse, dot two-tailed, probability is still that. And instead of this degrees of freedom, we're now going to use our adjusted df. And you'll see it gives us a slightly different, this is 1.96046, 1.96043. It is a slightly different t-value. So now that we have that, we can build our confidence interval just following the formulas before. It's a difference of means, so Amazon mean minus Apple's mean. We're going for the lower end, so we're going to subtract the positive t-value. All of that times the square root of the Amazon variance divided by Amazon sample size plus Apple variance divided by Apple sample size. And we get the low end of our confidence interval. Now let's do the upper end. So again, this is going to be a difference of means. So Amazon minus Apple, and now we're adding our t-value because this is the upper end. We want it to go up. And that's going to be multiplied by the square root of the variance of Amazon divided by the sample size of Amazon, again, plus the variance of Apple divided by the sample size of Apple. Okay, and again, negative over here, positive over here. That's a good indication that we got our confidence interval done correctly. If you got on your low side the positive and on your high side the negative, you know that you screwed it up. That's impossible for the negative number to be bigger than the positive number, so you need to go back and check that again. So now we have one more mean confidence interval to do before we get to the other ones. This is a two-tailed interval estimate for the difference in means, assuming non-normal distribution and not equal variances, but large n. So now, and I'm pretty sure this is going to be on the test because it's a tricky one, you have a z-value instead of a t-value because we have a large n, meaning we don't need adjusted degrees of freedom. So if you don't watch out for that, then you'll spend a lot of time doing your adjusted degrees of freedom when you don't need to. So as soon as he says large enough n, go for the z-distribution, it's your best one. So z-value, again, in Excel, we have to divide our alpha by 2 for Excel because there's no two-tailed option. So let's do our z function. It's norm.s.inverse because we're feeding it a probability. That gives us our z-value, which comes out negative. So now for this difference of means, we're going to take the mean of Amazon minus the mean of Apple, and we're going to add our z-value because a plus and a minus makes a minus, and this is our low end, so we want it to go down. Add the z-value and multiply that again by the square root of the variance of Amazon divided by the sample size of Amazon plus the variance of Apple divided by the sample size of Apple. And that very simply gives you the low end of your confidence interval. Let's do the high side now. So again, norm.s.inverse. We're going to plug in our handy dandy oh, my bad, I did the wrong one. Running on autopilot here. Sorry. We are doing the upper end of the confidence interval. It is the mean of Amazon minus the mean of Apple, and this time we're going to subtract our z-value because negative and negative makes positive, so it's the upper end, times the square root of the variance of Amazon divided by the sample size of Amazon plus the variance of Apple divided by the sample size of Apple. Again, you can see how easy this is as long as you get intuitive numbers like the low side's negative, the high side's positive, or the low side's smaller than the big side. You just plug and chug with your formulas and it's very easy to do. Okay, 2 more to do. These we're working with the variances now, so we're no longer working with t and z, we're going to be working with chi and f. So first is we can look at each variance individually, independent of each other, and see if they're significant. So let's start with the variance of Amazon. It's a two-tailed interval estimate for the variance assuming normal distribution. So normal distribution, sababa, that means that we're going to be going with chi because we're using variance. So first the chi square value. Again, there's no two-tailed option. So we had to divide alpha in half ahead of time. And we're going to be going for the inverse because we're feeding in a probability and we're getting a number. And the degrees of freedom here again is just n minus 1. So we get the low end. Now you'll notice here that I have a chi-square value left tail and chi-square value right tail. This isn't just for Amazon and this isn't just for Apple. I'm just using the same chi-square values for both because they have the same degrees of freedom and the same alpha. So since the distribution is identical for both, I'm just going to calculate the left tail and right tail one time, and I can use it for both tests. So let's calculate our right tail now. There's two different ways to do this. I'll show you both. The first way is the way we just did it. You use chi-square inverse, and you do 1 minus your alpha, and then you plug in your degrees of freedom. And what that's telling it is this alpha is very small. It's the leftmost part of your chi-square interval. And so the 1 minus this tiny number will give you a very big number, and that would give you the rightmost percentile of your chi-square distribution. So that's one way that you can do it. And the other way I have here, you can see, is, here, I'll just redo that, is you can also do chi-squared inverse right tail. And that'll tell it, take this and subtract 1 for me. So you don't have to do the minus 1 in that case. Excel knows what to do because it's the right tail. You see you get the exact same number either way. So you can either do chi-square.inverse and then just do the 1 minus yourself, or you can have Excel do it for you. It's probably good to practice both because you won't have Excel on the test, but you could do whichever one makes more sense to you. It's fine. All right, so now for our confidence interval for Amazon. So this is our formula. We're very simply going to do the numerator first, which is the sample size minus 1, all of that times our variance of Amazon. And all of that is going to be divided by the chi-square values. Now, this is our low end of our confidence interval, and so we want to use our larger chi-square value in our denominator because the bigger the denominator, the smaller the number. Now, this is a little counterintuitive. You might think, well, it's the left side of my confidence interval. Shouldn't I use the left side of my chi-square value? But no, for your confidence interval, remember, on the low end, you want the smaller number, meaning you'll use a bigger denominator. And you can see that here as well. In the left side, this is the 1 minus alpha over 2, which is exactly what we did to find this. And this one is just the alpha over 2, which is what we did to find this side. So that'll give you your low end, and we should get a bigger number here to prove that that's right. So now the other side is just going to be the sample size of Amazon, again, minus 1. All of that times the variance of Amazon, and divide that by, this time we're going to divide by the smaller chi-square value because we want a bigger number. So the smaller the denominator, the bigger our number. And we can see we got 0.00040 and 0.00045. So this number is indeed bigger. Now let's do the same exact thing for Apple. Again, we're going to do the sample size of Apple minus 1 times the variance of Apple, and all of that divided by, again, the larger side, right? The 1 minus alpha over 2 side to give us a smaller number. And then, again, we're going to do the sample size of Apple minus 1 times the variance of Apple, all of that divided by the smaller chi-square value to give us the upper end of our confidence interval. You can see 0.00025, 0.00028. This one is slightly bigger, so we did it correctly. The last one that we're doing, instead of looking at each variance individually, is we're going to compare the variances of the two stocks or two companies. So in that case, we're only going to have one confidence interval since we're comparing between them. And again, just like before, we're going to have an F value for the left tail, F value for the right tail that they're going to share because it's the same distribution, same degrees of freedom, and same alpha, so there's no need to do it twice. So first, let's come up with our F value left tail. It's similar to what we had to do for chi-square where there's two different ways to do it, so I'll show you that. First, we have F dot inverse for our left side, and you simply plug in your degrees of, alpha, which you had to divide by 2. And degrees of freedom, since we're working with 2 samples now, we'll plug it in twice. So that gives us the left side of our F tail value. Now let's do the F value for the right side. There's 2 ways to do this. The first way is F dot inverse, just like we did before. And you're going to do 1 minus your probability to tell Excel, okay, I want to look at the rightmost, uppermost side of my F distribution now. And again, plug in degrees of freedom twice. Or you can do F dot inverse dot right tail. and simply plug this in, and Excel knows to turn this into a 1 minus that alpha by itself. Plug in your degrees of freedom twice, and you get the exact same number. So whichever one makes more sense intuitively to you. It's helpful to note, again, in the formula that it tells you which side to divide by, whether you're doing 1 minus alpha, which is this one, or just alpha over 2, which is this one. So that might help you keep track, but either way is correct. Now let's do the confidence interval, again just following the formula. We're going to have the variance of Amazon divided by the variance of Apple, and all of that is simply divided by the larger f value to get the smaller end of our confidence interval. Very simple. And then for this one, we're again going to have the variance of Amazon divided by the variance of Apple, and all of that is going to be divided by our smaller f value to give us a bigger number, which you can see we got. So that's how these confidence intervals are calculated, and if you understand how all these different functions work in Excel, and you understand how to build these confidence intervals, you should be good. And once you build a confidence interval, it's very simply a matter of taking the number or statistic or percentage that he's asking you to test, and if it falls within your confidence interval, it's not significant. Like if we were testing 1.5, we would say, no, it's not significant because it falls within our confidence interval. And if we were testing 1, then we would say yes, because it falls outside of our confidence interval. It's just that simple.